So I'm going to talk about prevention in the vineyard. We're going to start with some basic, what we know about certain things. And then I'm going to talk about barrier sprays, which gets to Joel's question about, is there something we can use to absorb some of these things before they get to our food? So we'll talk a little bit about that. I'm going to talk about the sensor networks that we're putting in as well, because I think these are all things that go into things that we do to try and work towards prevention on the vineyard side. You'll hear later about mitigation on the winery side. So first things first, how does smoke get into the fruit? We think by now we know the answer to that question, but I don't think we do entirely. So early work, some of Kristen Kennison's work way back 2007, 2008, they talked about translocation of glycol from the leaves to the fruit. Later work kind of showed that it's possible. They did some work with labeled glycol, deuterated glycol, and showed you get deuterated glycol glycosides so they painted on the leaves, and later on you'll see these glycosides of deuterated glycol in the fruit. So it's possible, it does happen, but then they wanted to say that that's not the major route. We've done some work recently that suggests maybe 25 to 33% of what we see in the fruit actually comes from the leaves. So we can't overlook translocation as part of this, which has a big impact because when we start talking about barrier sprays, a lot of our early work focused on, based on the Australian suggestion that leaves didn't matter that much, we focused on protecting the fruit only. But if some of it is coming from the fruit, then that means we're going to need to put barrier sprays on the canopy, not just in the fruiting zone. So we'll come back to that a little bit later. So some other things. I said earlier today, we talked about ash, and here we are. So one of the first studies really that came out dealing with smoke impacts and smoke taint was from Australia in 2003, Hodges paper, and they reported they were concerned about ash because you've probably seen in some fires, there isn't much ash. In other fires, there's a tremendous amount of ash. And so there are instances where ash is in the canopy. And so the natural inclination is to try and remove that because that can't be good to have ash in the canopy, right? So they looked at if you remove the leaves and then do a high pressure cold water wash, you can remove the ash, which seems kind of extreme to go to the effort of removing the leaves because you're going to need those leaves still, right? Unless you're ready for harvest now, you're going to need those leaves. And even if you are going to harvest now, the plant will want those leaves to store stuff before the season ends. Kennison's work showed that if you wash the canopy without removing the leaves, you actually end up with more smoke compounds in the fruit. And that's largely because you're washing the stuff off the leaves into the canopy or into the cluster, and then it's in the cluster for when you make wine out of it. So I guess if you're going to remove ash, you've got to remove the leaves. But the question is, do you need to remove the ash in the first place? So we looked at this in 2020, and we found that freshly generated ash, so we do what we do, we burn some stuff and looked at what was in the ash. And it does have glycol, it has 4-methyl glycol, it has most of the things that we're interested in. But if you look at that same ash 24 hours later, it's dropped by about 2/3 compared to what it had freshly prepared. And you go a day later, there's almost none left. And so whatever is in the ash to start with doesn't stay there very long. It gets released back into the air. Some of it probably gets released into your fruit while it's sitting there. But if it's been there for more than 24 hours, whatever it was going to do, it's done. So don't worry about washing it off. What happens if you have ash that makes it into your fermentation? So it's caught in your cluster and you ferment it. So we looked at some smoke-affected fruit from 2020 because smoke-affected fruit turns out to be easy to get. They were not going to use it, so if we wanted it, it was all ours. So we took this Cabernet that had some smoke impact, and we added 1/4 gram per liter or kilogram, depending on whether it was red or white, of freshly prepared pine ash, less than 24 hours old. To another set of fermenters, we added 1/4 gram per liter of aged, I'm going to be really careful how I say this, aged ash. Aged ash, 7 days, that we prepared the week before. And then we also took 2 grams per liter of Cabernet leaves from the same vineyard. So we know the leaves had been smoke affected, and we added those to other fermenters, fermented them for 10 days. We did this in both Cabernet and Riesling, but I'll show you the Cabernet this time. In case you're wondering what 1/4 gram per liter of ash looks like. Yeah, hopefully, hopefully it never comes to this, right? That's what it looks like. We added to the freshly crushed fruit. And this is what it looks like when you do the analysis. So in blue, we have guaiacol. In red, we have 4-methyl guaiacol. As I said, the control is the first pair. The control wine the control fruit had been smoke affected. That's why we had it. And so it had, 3 micrograms per liter almost of guaiacol, a little less than 1 of 4-methyl guaiacol. At the end of the fermentation, if you look at the one that had the freshly prepared ash, you see an increase in both guaiacol and 4-methyl guaiacol. So if you're picking your fruit and the ash has fallen in the vineyard, this is a concern. If the ash fell in your vineyard last week, whatever it was going to do, it's already done. Probably most of what was in that fresh ash gets dispersed to the atmosphere. Some of it is going to go into the fruit, but it won't be all of it. But you can see the aged ash, the values look the same as the control. So there's no impact from ash that's been sitting around for several days. Fresh leaves. Fresh leaves add a little bit of guaiacol, but they don't really seem to make much of a difference for 4-methyl guaiacol. And we saw similar outcomes when we looked at this in Riesling. Okay, so ash is probably not a whole lot we're going to do about it. The fire has a lot of ash. There's going to be a lot of ash in your vineyard. It's going to emit some guaiacol and other compounds, and some of that is going to end up in your fruit. But there's probably not a real reason to try and remove it. Okay. So I want to talk a little bit about barrier sprays. The barrier sprays are materials that we can apply usually before, sometimes during, depending on the circumstances. You might be able to put a barrier spray on. And the idea is we, as Joel suggested, maybe want something that will intercept some of these compounds before they get to your fruit or to your canopy. So we know that we need to be concerned about the canopy as well. And there are a range of different materials that people have tried. Many of them are adsorptive materials like kaolin or bentonite. These are powders, finely divided clays. They're very adsorbent. They will remove, if you're winemakers, how do you test for TCA in your cellar? You use a bentonite trap. You use a bentonite trap because it's going to absorb the TCA that's in the air in your cellar. You can use bentonite as a barrier spray on your canopy to remove guaiacol and other marker compounds from the smoke before it gets to your fruit or your canopy. So that's the idea there. Kaolin is just a variation on a theme. It's another powdered clay that has similar properties to bentonite. And so we can put these on in the vineyard before an exposure, or in some cases, maybe if it's not a worker health issue to be out there, you could conceivably apply these once the smoke has started. So one of the things that kind of requires is either we have to do the work to show that we can have these on the vineyard kind of all the time, and it doesn't cause a problem, or we have to have good models that tell us the smoke is coming your way and you need to be prepared. Hopefully you can cover your high value vineyards first and then move on to lower tier vineyards as time allows. There's another set of barrier spray materials that other groups are working on. Elizabeth is working with a team at Oregon State on some polymeric coatings that provide a physical barrier, something that will stretch with the berry as it grows, potentially. And my concern with some of these is there may be an absorption effect as well. It's not just a physical barrier, but it's actually absorbing these materials from the smoke plume. So we're not the first to look at these. Kerry Wilkinson's group in Australia looked at the use of kaolin as a potential barrier spray for removing volatile phenol glycosides in smoke exposed fruit. So they were looking at this as an opportunity to reduce uptake during an event. And in their work, they found it really depended on how much you put on, how good your coverage was. And I fully agree that application rate and coverage, how well you can cover, is going to be a big role. They suggested that there was a varietal effect as well, that it didn't work as well in protecting Sauvignon Blanc, but better reduction in Chardonnay and Merlot. My guess is that has not so much to do with the kaolin itself, but the response of varietals to smoke generally. The other thing that they came out of this study was when they went to look for free compounds, so glycols, 4-methyl glycols, et cetera, very quickly, once the smoke exposure starts, these things get converted into glycosides. We've heard some about that already today. That pathway gets upregulated fairly quickly within the first 12 hours or so. We start to see glycoside pathways coming on. So it's not surprising that when they go to look for these compounds after the smoke clears, they're not finding them in the fruit because they're already been converted to glycosides. So one of the questions, and I had a chance to ask Kerry this one time, was whether or not they removed the kaolin before they did their analysis. Because in our experience, that makes a big difference. And I'll talk about that in a minute or so. And she actually didn't have a clear answer. She wasn't sure in each study whether they had removed the kaolin or not. So she deferred to go back and give me an answer. So we've been looking at this since 2018. We started this with actually a high school science teacher over in Pasco who was part of our lab for that summer, and he was there on a grant that to give him some experience in doing research to help him be a better science teacher. And we gave him this project at that point, just a sort of a side quest to look at whether we could use things like kaolin or bentonite as barrier sprays. And in the first year, we sprayed the materials on the day before we did our exposures, and we didn't really find a big difference between the vines that were treated with kaolin or bentonite and the ones that were not. So we went back and did this again in the second year of his grant, and we looked at it. So in 2019, we did it again. One of the things he did in the first year, we did whole berry extract. So we just crushed the berries, took samples of that to look at what was there. Second year, I said, well, we know these compounds are in the skin, so let's just look at the skins. So he's peeling the berries, and as he's peeling the berries, he's wiping the kaolin on, right? That's just part of what happens when you're trying to peel a berry. So he wiped all the clays off as part of his sample preparation process. And when we looked at the outcome, first on the left, the three CX, CK, CD, these are the controlled. Thankfully, there's no glycol in our controls. We didn't get any glycol in our unsmoked fruit. SX is the unsprayed control, but in the smokehouse. SK is the kaolin sprayed. SB is the bentonite sprayed. And you can see when you wipe the kaolin or the bentonite off the fruit, you see something like, the scale's not there, but it's about a 40% reduction in the amount of glycol or 4-methyl glycol or cresol when you use kaolin or bentonite. Bentonite was actually a little bit better, but I kind of like kaolin because you can see there's a picture there of what the vine looks like when it's sprayed with kaolin, and it's quite clear that it's been sprayed. What does bentonite look like when you spray it in a vineyard? It just looks like the vineyard's dirty. It's brown, it's not white. I like the white one, even though it's not quite as effective. you know it's been sprayed, and you know when you wash it off, that it's been washed off. So we've continued to work with this with kaolin rather than bentonite because we wanted to take advantage of the fact that we can actually see the kaolin. And so in 2020, we did some trials, but they were basically wiped out by the smoke for the 2020 season. So we went back and looked again in 2021, applied the materials the day before we were going to do a smoke exposure. So we start at 7 o'clock in the morning. The afternoon before, when it started to cool off, they went in with backpack sprayers, sprayed the slurry of kaolin or bentonite, half a pound, so it's 2 pounds in a 4-gallon backpack sprayer. So half a pound per gallon, which is about the rate that you apply if you're using a surround. And then after the smoke cleared, we went back in 7 days later. And on half of the treated vines, we washed the material off, again, using the backpack sprayer and water. We just washed as much of the kaolin or bentonite off as we could. And the other half, we left treat coated because we wanted to see, do we need to remove this? Is what we saw in 2018 and 19 a fluke, or does it really matter if you wash the kaolin off? So we did that. And you can see in this picture, there's some drips of kaolin. It's not, we used a backpack sprayer. You probably, if you were going to do this commercially, it'd be an air blast. You'd put a lot more kaolin on in the first place, and you'd have a much better chance of getting the kaolin off once you were at that point of the process. And then at the normal time, we would do our bucket scale fermentations with the fruit. And then we did analysis of free and total volatile phenols, again, using GCMS and acid hydrolysis for our method to look at the totals. So this is what it looks like. So blue is the unrinsed, yellow is the rinsed. And when on the left side, in this case, we have free glycol, and free glycol for these was 35 to 45 micrograms per liter. So much more intensely smoked than what you tasted earlier this morning. We had fun this morning, but not as much fun as you could have. So these wines were intense. But a couple of interesting things. If you just look at free glycol, it looks like even on the unsprayed control, where all we're doing when we rinse is wash off fruit that never had anything sprayed on it, there's a reduction in the amount of free glycol, just like there is for kaolin and for bentonite. Not a big reduction, but there is a reduction. But in this case, yeah, we've got 40 micrograms per liter of free, but we've got 170, 180 micrograms per liter of total. So 3 to 4 times as much total bound as we have free. And when you look at the first pairing in the total side, that's the unsprayed, so it wasn't treated with anything. And when you look at total glycol, there's no difference whether you rinse or don't. The number is the same. So it's not a real phenomenon that you can wash glycol off your vine. I want to make that clear, because if you just look at the data, it suggests that's possible. But when you look at the total, there's really no difference between the unrinsed and the rinsed. When you look at kaolin, there is a big drop in total glycol when you use kaolin, when you use bentonite, as long as you rinse it off. You do see a reduction. So rinsing does matter. You've got to wash this stuff off. And in particular, the reason you need to wash this stuff off is if you don't do anything, you don't rinse it, it actually makes it worse. The total number is higher. If you spray kaolin on your vine and leave it, it actually gives you more total glycol than if you had just stayed home and watched Netflix and didn't do anything, right? So you do have to wash these absorptive materials off. We're working now on trying to figure out, how long do you have? Do you need to do it the day after it clears? Do you need to do it? In this case, we did it within a week. And within a week, we still saw a protective benefit if you rinsed it off. We've looked at not rinsing it off or rinsing it off before it goes into the fermenter. And by the time, if you harvest the fruit and then wash the fruit before you ferment it, you're already in that situation where you've made it worse. So you really do have to go in and wash this stuff off. And that's why I'm concerned about some of these polymeric stuff materials, because if they have an absorptive part, they are going to have to be washed off as well. Because it's, the smoke clears, some of that stuff that's in the kaolin is going to be released into the air. Some of it's probably going to be released in the fruit, just like it was with ash. Last thing I think I want to talk about is air quality monitors. We have been using this kind of monitor routinely in our delivered exposures. We're looking at PM10, 4, 2.5, PM1, just looking at the different particle sizes of smoke. We are mostly these days measuring just PM1. After 2020, we started on a project to put air quality monitors out in commercial vineyards. The blue TSI monitors that I showed you originally, those cost about $6,000 a piece, so we're not going to put those in a lot of vineyards. But there are less expensive monitors available. Most of them are designed for PM 2.5 for human health purposes. Some of them actually include chemical sensors as well, so you can get CO, CO2, ozone, things like that. And we've been working since 21. It was part of the SCRI grant to put these sensors out in commercial vineyards. So we have something like 22 of these out in various vineyards around the state of Washington. We started doing things to get at this topographic question. So there are places where we have 5 or 6 monitors within a mile of each other, and they're where they at because we've got an elevation gradient from down by the Yakima River to fairly high up on the Red Mountain. So we can start to look at and provide actual data for the modelers on what it looks like in these different locations that are pretty close geographically, but vary by elevation, vary by where they're at relative to wind tunnels in that area, things like that. We had some supply issues with the first sensor, the one I showed you before. So we're now working with Oregon State, building. These sensors are being built at Oregon State using design from Bob Coleman. We've had these out in Oregon, Washington, California for the last 3 seasons. We have 15 of these, plus we still have about 7 or 8 of the original thingy sensors. And we've got them all over the state of Washington. There are critical areas in Oregon and in California as well. So this is part of the SRI grant. This will be part, I think, of the next grant going forward. And again, the idea is these are giving us data that helps support modeling, also provide us information to tell you what's happening in your vineyards. One of the key things about having these out in vineyards is this is highly localized data. It's specific vineyards, and it doesn't take very long for people to figure out where these are. And so you don't necessarily we have to be kind of careful about how we use this data and who has access to it. So it doesn't end up with some sommelier in Dallas deciding they're not going to buy wine from this winery because of what they saw with the sensor data, right? So we have to be careful how we use it. Hand in hand with the sensor data, these sensors generally give you primarily particulate matter counts, so smoke density, how many particles per cubic meter. There are a few that do things like ozone, CO, CO2. So we're also using TNAC sorbent tubes, the tubes you see up on the upper right, connected to an air pump like you see on the lower right. We can go out and collect. We use these routinely when we're doing our delivered exposures. If there's an exposure, an actual event, we would use these to go around and collect samples at different locations, trying to chase the bloom, as Mike suggested earlier. There are other similar systems. These are sorbent tubes. We also have whole air canisters where we can collect an entire sample of air. There are Tedlar bags. There's a number of those. So this has in the last 3 or 4 years been a key part of what we're doing to get more information about what's in our smoke. And I see this being part of the SCRI program going forward. The last thing I'd say is we've been doing this for a while. And this is a list of the people that have been involved in this project just here in Washington over the last several years. It's postdocs, it's graduate students, as undergrad researchers, we provide lots of opportunities for undergraduates here to get experience doing research. Some of the people around here are high school science teachers from mostly from Pasco. So there, I mean, it takes a lot of people. If you're going to be out there for 36 hours doing an exposure, we work in 8-hour shifts. And we rotate people, and just to do one exposure takes 6 or 7 people to be able to staff this, so that we can do this, be safe, collect the data we need to have. So there's a lot of people that you're supporting with your letters of support with the money that we're getting. So thank you to all those that are involved. And thanks to the growers that are willing to provide us fruit, like what we use for the Cabernet study, and the ones that are willing to have PM1 monitors in the vineyards, even though someone in Dallas might take exception to the ones that's within there. Okay, so that's it for me. Do we have time for questions?
You have time. Have you done any measurements to understand if kaolin impacts photosynthesis?
We have not. I assume that could be a problem, that work has been done as part of getting it registered for use as surround. But we have not done that kind of measure. And again, part of that is, in our case, we're doing our exposures under 80-20 shade cloth. So that kind of gives me an easy out for anything related to photosynthesis. Sorry to say.
However, when you're rinsing that off, it's literally getting rinse on the vine sitting out the finger. Is there any potential unintended consequences or side effects again with that increased concentration now that you're just falling straight back down into the soil?
Sure.
And or has it absorbed more and concentrated more than if it had just been left natural and the pollutants had just gone straight through the vineyard?
Well, I mean, I think if you look at the total results, it's very clear that it is concentrating from the air, because the number, if you don't do anything, is lower than the number that you get if you put kaolin on and didn't take it off. So it is definitely pulling things from the air, and some of it at least goes into the fruit. Are there other consequences, unintended consequences? There may be. Part of this, I think, might be mitigated if you had a better system for washing it off at the end. Backpack sprayers do a reasonable job, but I think air glass would be better. Is there a consequence of having this kaolin with smoke on it, smoke compounds in it on the ground? Possibly. I would say that the fact that when you rinse it off shows less in the fruit says we're not getting a lot of it coming from the ground up in the fruit. I think most of what's happening when you don't rinse it off is direct release. It's what's being released, because when the smoke is heavier than what's the concentration in the kaolin, it's going to go into the kaolin. When the smoke clears, some of what's in the kaolin is going to go back out into the atmosphere. And I think that's where this is coming from. Some of it goes into the atmosphere, some of it's then reabsorbed by the fruit. But I think that's going to be true of any of these kinds of materials. And so it's fair warning that if we're going to use these, they can be helpful. And they probably are even more helpful than this suggests if you do a better job of coverage in the first place, and if you do a better job of removing them second.
It was kind of that, are there any risks of getting a short-term benefit, or sorry, short-term gain, but a long-term negative potentially?
Yeah, and that would require more, I mean, it's just going to take more time to. But I think there is a benefit, but there is always the potential for risk. Yeah, there are really questions over here.
In washing off the kaolin at the end, does that then disrupt the ability to do a native yeast fermentation?
I don't know. I mean, you're doing the pesticide application routinely anyways, and so you're always spraying something in your vineyard. So
Right.
I don't think you're going to have to put so much water on that you're going to completely remove. But this is the kind of thing that we could actually have Devin Coleman Durr's team look at, because they do microbial ecology. They did some of their work was done in our vineyards during our exposures. So I don't think that's a big risk, but
I would assume not either, because in his work, he saw a really large rebound after, I want to say 7 days
Yeah.
or something. So even just if you're banging yourself, your microbiome is gonna grow quite.
Come
rapidly.
back.
Yeah,
Okay,
I mean, the
awesome.
microbiome is definitely affected by the smoke. That was one clear
Sure.
message from his work. But it was also clear that the recovery was fairly quick. So there probably is some impact. You're probably gonna wash some things off, but I don't think it's going to prevent you from doing. I mean, I think the bigger prevention from doing a natural fermentation is the smoke itself.
Sure.